Hello, welcome to PhyzQuest. So this is the video solution for CSIR NET December 2019 Part C question number 9. The question is, let the normalized eigenstates of the Hamiltonian H be psi1, psi2 and psi3. We need to find out the expectation value of the Hamiltonian and the variance of the Hamiltonian in the state psi, which is equal to 1 by root 3 of psi1 plus psi2 minus I psi3. 4 options are given and we need to choose the correct option. So let's get started. So this question comes from the section quantum mechanics and the concept involved here is the eigenvalue problem. So in this question we are given a 3x3 Hamiltonian H, which is this, it's a 3x3 matrix form, and a state psi which is a combination of eigenstates of the Hamiltonian, that is psi1, psi2 and psi3. So the wave function is 1 by root 3 psi1 plus psi2 minus I psi3, and we need to find out the expectation value and the variance of the Hamiltonian. In order to solve this problem, we need to proceed step by step. So here we need to find out expectation value and the variance. So any quantum mechanics problem, before calculating any parameter, we must check whether the given state is normalized or not. So to check whether a wave function is normalized or not, we need to multiply the wave function with its complex conjugate, and it should be equal to 1. Then psi will be a normalized wave function. If it is not equal to 1, then psi is not normalized. But then this psi star psi should be some number. Let us suppose this is equal to n. Now in that case, in order to get a normalized wave function, we need to multiply the reciprocal of the square root of the same number with the original wave function to become a normalized one. So here in that case, here 1 by square root of n into psi is a normalized wave function. Now in our case, if this is psi, then this complex conjugate will be 1 by root 3 psi1 star plus psi2 star plus I psi3 star. So the product of psi and its complex conjugate will be equal to 1 by 3 psi1 star psi1 plus psi2 star psi2 plus psi3 star psi3. I minus I into plus I will be equal to 1, it will be plus sign here. So now here, as it is already mentioned in the question itself, that psi1, psi2 and psi3 are normalized wave function. Therefore, their product with its complex conjugate will lead to the answer 1. Each of them will have a value 1. So this will be equal to 1 by 3 into 1 plus 1 plus 1, which is 3 by 3, which is equal to 1. Which means psi is already a normalized wave function. So once we have got the normalized wave function, next we need to, in order to calculate the expectation value and variance, so first of all we need the energy eigenvalues of the Hamiltonian. So the second step will be calculation of the eigenvalues of the Hamiltonian. So here the Hamiltonian is a 3x3 matrix. To calculate the eigenvalues of this Hamiltonian, we need to solve the characteristic equation, that is the determinant of H minus lambda I is equal to 0. So here I is the identity matrix and lambda is your eigenvalue, which is assumed. So now when you write it in full form, this will be like this, and when we solve it, ultimately this will give you the upon the final calculation, the answer for this lambda or the eigenvalue will be equal to 1, 2 and 3. These are the 3 energy eigenvalues we have got. And why I am saying energy? Because it is related to the Hamiltonian operator. So now these are the energy eigenvalues, that is 1, 2 and 3. Now we have got the eigenvalues as well as the normalized wave function. So next we can proceed with whatever is asked in our question, that is calculation of expectation value and the variance of the Hamiltonian. So before calculating, you must understand what is actually the meaning of expectation value and variance. See, expectation value means, in simplest form, expectation value of any quantity means the average value of that quantity obtained from a repeated measurement for a collection of identical particles in that same state. So you can consider it's the mean or average value of a certain quantity for repeated measurement. Now, what is variance? Now, variance is, see, when we while calculating the expectation value, when we take a large number of measurement, all the measurement value will not be exactly same as the expectation value. This will actually spread near the, it will be scattered near the expectation value, or you can say it spreads around the measurement around this expectation value. So if you try to understand it graphically from this plot, if this line represents the expectation value of a quantity, this curve surrounding that line, the spreading, this represents the variance. Now after this literal meaning, we can move ahead with our calculation. So first of all, the expectation value. So expectation value, to calculate the expectation value of the Hamiltonian, this can be written as psi star h psi, which will be equal to 1 by root 3 into 1 by root 3 psi 1 star h psi 1 plus psi 2 star h psi 2 minus I into I psi 3 star h psi 3. So upon operating the Hamiltonian with this wave function, this will be ultimately lead to 1 by 3 E1 plus E2 plus E3. So here E1, E2 and E3 are actually the eigenvalue corresponding to this eigenstate psi 1, psi 2 and psi 3 respectively. Now one thing I'll mention here is, here though we have calculated the eigenvalues, that is this lambda is actually lambda equal to 1, 2 and 3 are actually E1, E2 and E3, but we don't know exactly what is exactly E1 or E2 or E3. We only know the three values. We don't know which value corresponds to which eigenstate. But that will not affect our calculation here. Why? Because here in this wave function, as you can see, psi 1, psi 2, psi 3 are associated with the same coefficient, that is 1 by root 3. So since they are associated with same coefficient, their eigenstate, when you put the value here, you can see E1, E2 and E3. They have the same coefficient. So whatever value you put for any of them, we know the three values and we can choose whatever value for which one. That will not going to alter our final answer. So now in place of E1, E2 and E3, we will put 1, 2 and 3. So this will be equal to 1 by 3, 1 plus 2 plus 3, which is equal to 6 by 3, which is equal to 2. So this is our expectation value. Now here, this we can use a direct method, which I'll mention here. Suppose you have a general method I mentioned. So here, suppose the wave function psi has a form a1 psi 1x plus a2 psi 2x plus a3 psi 3x. This is a general form where psi 1, psi 2, psi 3 are eigenstates and a1, a2, a3 are associated coefficients. So now if you want to find out the expectation value of the Hamiltonian for in the state psi, this will be equal to a1, a1 star e1 plus a2, a2 star e2 plus a3, a3 star e3. So if you use this formula, this will be equal to 1 by root 3 into 1 by root 3 into 1 plus 1 by root 3 into 1 by 3 into 2 plus 1 by 3 into 3. Ultimately this will be lead to the same answer, which is 2. So we have got the expectation value 2. Next is calculation of the variance. Variance is mathematically represented as delta H, which is actually the difference between the expectation value of the square of the Hamiltonian and square of the expectation of the Hamiltonian. Okay. So first we will calculate the expectation value of the square of the Hamiltonian. So here use the general formula for psi, then expectation of h square will be a1 a1 star e1 square plus a2 a2 star e2 square plus a3 a3 star e3 square. So now we will put the values of a1, a1 star. Ultimately this will be 1 by 3, 1 square plus 2 square plus 3 square. Again it will not going to alter the final value, because as I said, each of the eigenstate have the same coefficient, that is 1 by root 3. So final answer will not be affected even if we don't know exactly what is E1 or what is E2 or what is E3. So ultimately when you finally calculate it, this will be equal to 14 by 3. So we have got the expectation of h square, and we have already calculated the expectation of h. So we'll put the value in the formula of delta h, that is the variance, which will be 14 by 3 minus 2 square, which is equal to 14 by 3 minus 4, which is 2 by 3. So we have got our expectation value as 2 and variance as 2 by 3. Now let's check the option. Now if you check the option, you can see that option C is matching with our result. So the correct answer for this question is option C.